There's a very nice feature in Haskell called list comprehension. It can be argued that something that very many programming languages struggle with is being able to represent set theory nicely. It would be nice if we could talk about sets in the same way as we do in mathematics. In Haskell, we have something that's very similar to set abstraction. Set abstraction is something we know from mathematics. For instance, we could define the set of even natural numbers to be the set of n belonging to the set of natural numbers for which there exists an I in the set of natural numbers such that n is 2 times I. Now that's a very nice way to define the natural numbers. And we could do something very similar in Haskell, only for lists. We can define the set of even numbers, evens, as the list of all numbers that are of the form 2 times I, where I belongs to the list, and here we're talking about a range, 1 dot dot. And if we type this into Haskell, everything looks fine. Evens is the list of numbers 2 times I, where I is taken from the range 1 dot dot. Let's see if Haskell likes that. Haskell was happy with that. We could try finding all the evens. Oops, we have to break that. A better way to find some even numbers is to use the take function. Let's find the first 15 even numbers this way. Yep, there's the power of lazy evaluation for you. One has to be very careful when using generators. In the definition that we've just seen, this is called a generator, and its role is very similar to the role of this in a set abstraction. Tells us where to take the elements of a set from. This tells us where to take the elements of a list from. One has to be careful when using generators, because if we use more than one generator and the second generator is an infinite list, we run into problems. Here's an example of that. Now let's try to find the numbers of the form I, j, where I is taken from the list 1, 2, and j is taken from the list of natural numbers, so it's 1 dot dot. And notice that we use comma to separate generators here. We want to find the first 10 such numbers, or 10 such pairs rather, and then we want to call that something. We'll call this first 10. Let's see what Haskell says. Yes. Haskell likes that. What is the value of first 10? It's, and here's the problem, because all the elements in this list are pairs where the first component is 1. So that's not what we want. The trick is to use a nested sequence of list comprehensions. So instead, let's write the list of ij where I is taken from the list 1, 2. Where it's the case that j is a natural number. Let's see what Haskell says about that. Haskell was happy about that. What is the value of first 10 now? Ah, that's much nicer. So that also structures the list a bit. We get 1, 1, 2, 1, 1, 1, 2, sorry, 2, 2, 1, 3, 2, 3. And if we're only interested in the first 10 of these, we could flatten this list and then take the first 10 elements of that. Anyway, those were generators. We can use generators to specify where the elements of a list in a list comprehension come from. But we could also use something called guards if we want to define the list of even numbers that are divisible by 7. We could define the list even sevens. That would be the set of numbers of the form 2 times I, where I is taken from the infinite range 1 dot dot, so it's a natural number, and 2 times I modulo 7 is equal to 0. Let's give that to Haskell. Haskell was happy. Let's find the first 7 numbers that are even and divisible by 7. So we could take 7 from even sevens. What do we get? Well, probably what we expected. So note that what we have here is a guard. It's an expression that can evaluate to a truth value. And of course, everything that's mentioned in this guard must be something that we know already. The I that we mentioned must be a member of a range that we mentioned earlier on, that is to the left of the guard. So that's what you can do with list comprehension. It really is quite powerful. But well, even though list comprehension is powerful, list comprehension is actually something that we could define already. List comprehension, that's actually ranges. We use ranges to define generators, and we can use filters. We've seen those already, how you filter a list to define guards. So ranges can be used for describing generators, and filters can be used for describing guards, and you can systematically translate any list comprehension into an ordinary list expression if you want. I'll leave you to think about how to do that. It's an interesting little exercise.